Alright guys, today's goal. The learner will understand trigonometric functions and of acute angles. Okay. So solve for x. Quick review. Well, here's Pythagoras. Well, we have to assume these are right triangles. So x squared plus 3 squared, or x squared equals 3 squared plus 2 squared. A squared plus b squared equals c squared, Pythagorean theorem. So x squared equals 9 plus 4. X squared equals 13. Why is it only positive root 13? Because it's the angle, or it's the side length of a triangle. So here you'd have x squared plus 3 squared equals 6 squared. X squared plus 9 equals 36. So x squared equals 27. So x equals square root 27. You can use calculators to approximate if you want. Hopefully I didn't do any mental errors there. Oh, I did forget to do something. Check to see if you can simplify. Because we can make that 9 and 3, so that would be 3 squared 3. Convert 9.3 inches to feet. 9.3 divided by 12, whatever that is. Solve for a here. It'd be a equals 20 times 0.45. And this one, it would be b equals 36 divided by 1.72. I think this one, let me grab the calculator real quick, is 9. And the other one, 20.93. Okay? There we go. Alright, what you learn about. Right triangle trig. Do you remember this? So, ka, toa. And the two famous triangles, the 45-45-90 and the 30-60-90. You'll have to remember ratios for those. Evaluating trig functions with a calculator, and then applications of right triangle trigonometry. And why the many applications of right triangle trigonometry gave the subject its name. Okay? Alright. An acute angle in standard position with one ray along the positive x-axis and the other extending into the first quadrant. It's got to be in the first quadrant because acute means between 0 and 90 degrees. Okay? See, here's the SOHCAHTOA. Sine equals opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent, opposite over adjacent. Now, cosecant is the inverse of sine. See how it's just flipped? Secant is the inverse of cosine, so it's hypotenuse over adjacent. And tangent, or cotangent, is the inverse of tangent, so it's adjacent over opposite. Okay? Now, real quick, remember, if I do 45, 45, 90, these are the same, and that's times the square root of 2. And then if you did the 30, 60, 90, it's x times the square root of 3, and 2x. Those are ratios we need to remember, okay? So using one ratio, find them all, okay? So if we think about this, call that theta. Tangent is opposite over adjacent. So this is 4, this is 3. So how could I get the other side? Well, how could I get the hypotenuse? Call it x. X squared equals 3 squared plus 4 squared. So that would be the square root of 13. Nope, square root of 25. Which is 5. So I know this is 5 now. So what is the sine? Opposite over hypotenuse. 4/5. Sine of theta. What is the cosine of theta? Adjacent over hypotenuse. We already have the tangent, so what is the cosecant of theta? Well, it's hypotenuse over the opposite. What is the secant of theta? Hypotenuse over adjacent. And what is the cotangent of theta? Adjacent over opposite. See? So there we go. And we always want exact answers, not decimal answers, okay? So cosecant. We call this theta. Well, I know sine, it's the inverse of sine. Sine is opposite over hypotenuse, so this is hypotenuse over opposite. So for this one, you'd say 8 squared equals 5 squared plus x squared. So 64 minus 25 is 39. So x is the square root of 39. And that can't be simplified at all. So we leave it like that. So now sine of theta. Well, I already know that one's 5/8 because it's the inverse of that. Cosine of theta. Adjacent over hypotenuse. Secant of theta. Hypotenuse over adjacent. I'm not going to worry about making you guys simplify those right now, but we'll talk. Remind me to bring that up in class so I can talk about, we can remember how, because that's technically not correct. Tangent, opposite over adjacent, cotangent, adjacent over opposite. Okay? So there's all the other ones. Alright, common calculator errors. This first one, huge. Using the calculator in a wrong angle mode. So you need to check every time you're doing cosine or sine or tangent. If they give you degrees, you have to make sure your mode is in degrees. If you're given in radians, you got to make sure it's in radians. If you're not sure how to, ask and I will show you. And accidentally using the inverse key is another one. Instead of, using the inverse trig keys to evaluate cotangent, secant, and cosecant. That's what we have to be able to do. We'll talk about that if we come across a problem, okay? Using the function shorthand that the calculator does not recognize. Okay? And then not closing parentheses. So. Alright, well, hopefully we're remembering these things and recalling. Alright, a right triangle with an hypotenuse of 5 inches includes an angle of 43 degrees. Well, that means that one's not 57, 47. Find the measure of the other two angles. Well, it said right triangle, so one's 90, one's 47, and the lengths of the other sides. Well, if I use 43 here and call that x, call that y, I would say the sine of 43 degrees is equal to x over 5. So x equals 5 times the sine of 43. So 5 sine 43. Make sure your calculator is in degrees. It's approximately 3.41 inches. Cosine 43, adjacent over hypotenuse. You should always use the given side, don't go tangent. Cosine, so this would be 5 times the cosine of 43 degrees equals y. So you do 5 cosine of 43, and it would be approximately 3.66 inches. Let's see if we made any mistakes or didn't. So they rounded to tenths, I did hundredths, but there we go. And they somehow did the same angle for sine, so they got the side lengths right, but there's something not right in one of those. So, all right, well, be ready to do some work tomorrow. Hopefully this is just refreshing, not really anything new. See you then.